Hi, everyone. This is Dr. Collins. Just wanted to preface this week with talking about how difficult things have been for some of you. I'm aware. I've heard from a number of you that things are really tough right now. I'd really like to let you all know that if you need anything at all, please don't hesitate to reach out. I myself am suffering a little bit from the lack of structure. And so, if there's anything I can do to make your life a little bit better or easier during this difficult time, please let me know. I'm more than willing to do whatever I can to help all of you. So please, again, just let me know whatever I can do. All right. So this week we're going to talk a little bit about one sample Z tests. Now, these are not very common in political science. And so it's kind of hard to come up with a good example for it. So instead, I came up with kind of a nonsensical example that has to do with crazy graduate students and how much work they do. So that's why we have this particular picture here. All right. But this is really the first week that we're going to talk about what specific statistical tests we want to run. Okay, so this will start this week, and then we will run into t-tests. There's a couple of different varieties of that. We'll talk about chi-squared tests, and then we'll dive into regression. We're going to skip some of the stuff in your textbook. ANOVA, for instance, it's really not common in political science. So we're going to skip that, and we'll talk more about t-tests, chi-squared tests, and regressions. All right, but we'll start this week with a nice gentle introduction, one sample z-scores. All right, so let's dive in. So the agenda. Now, we're going to start by describing this crazy example, all right? And then we'll go a little bit more in detail into what a z-score is and why it might be appropriate in this case. And then we'll go through each of those 8 steps that your textbook outlines for statistical testing. Okay, and then we'll end by working through that example, calculating our z-score and determining statistical significance. Okay, so let's go ahead and dive in, shall we? So starting off with our nonsensical example. Let's say you're researching incarceration rates, right? So incarceration rates are typically defined as the number incarcerated per 100,000 population. So the Prison Project has a lot of good data on this. I went and pulled up data, the mean for, or the number for each state, okay, the rate for each state in the country. Now, let's say you are interested in regional variation, and we're just going to define regions very bluntly here as South versus non-South. So the South we'll define as the 11 former Confederate states, plus those 5 border states, right? Kentucky, West Virginia, Maryland, Delaware, and Missouri. And then we'll throw in Oklahoma because it was ruled by the 5 tribes who sided with the Confederacy and has a lot in common culturally with the rest of the South. So that's 17 culturally southern states. And then the remainder, of course, will be considered non-southern. Okay, so that's going to be 34 other states plus DC, right? So 33 states plus DC. Now, let's say that you have the means and standard deviation for each region's rate. All right, and I'll give those to you right now. So I've calculated these out. For the South, the mean incarceration rate is 902 people per 100,000. The standard deviation for those 17 southern states is 194. For the non-South, the figures are 572 for the mean and 180 for the standard deviation. Okay, so again, these are just the mean for all 17 southern states and all 33 non-southern states plus DC. Okay, and their standard deviations. Now, here's where the nonsense part comes in. Let's say you are going through the library and you find unidentifiable human remains, right, with a post-it note saying 842 incarcerated per 100K with an arrow pointing to it that says, that's the mean of 5 states I've lived. So we know nothing about this dead person except for where they may have lived, right, and the incarceration rate for the 5 states they've lived. Now, using statistics, it's your job to help the research team leader identify the remains by narrowing down the person's region of origin, assuming they only lived in one region. Of course, if they lived in states from different regions, then this wouldn't work. So we have to simplify it a little bit. So again, it's kind of a dumb example. Your textbook uses the example of a professor wants to know whether or not his current class is exceptional relative to prior classes, right? So you want to see basically whether or not this sample can come from a specific population, whether it matches that specific population. That's all we're doing here, right? We want to see whether or not this sample of 5 states matches the southern or non-southern population, all right? So to do this, we're going to use a one sample z-score, okay? Now, you might remember z-scores. We've talked about these in the past. It was even on your first exam where I asked you to calculate a z-score. Now, all a z-score is it tells us how many standard deviations away from a mean a given observation is. Okay, so a one sample z-score then tells us how many standard deviations, really standard errors, away from a population mean a given sample is. All right, so basically we're asking how likely is this sample to come from a given population, right? We're going to assess how likely a given sample is given a specific population mean. Okay, so this is related as well to your lab assignment for this week, right? Where I tell you that your sibling thinks that Jill Stein's true feeling thermometer should be in the 50s. Your sample says she's at 42. How likely is it that this sample comes from a population where the mean is in fact 55? Okay, so that's really what a one sample z-score is used for. Now, let's remind you of the statistical testing steps according to your textbook. So you start by defining the null hypothesis. In this case, it's a little weird, but we'll get to that. Then you set the threshold for significance. Okay, so generally, we're going to use 0.05. I'll go into some more detail on that in a moment. Then you select the appropriate test statistic. Of course, in this case, it's going to be that one sample z statistic. Then you calculate your sample test statistic. In this case, again, the one sample z-score. Now, here's where things get a little bit tricky. We have to determine a critical value that we must reach with our statistical test value in order to reach our significance level. Okay, I'll talk more about that, obviously. Then we compare our test statistic to the critical value. And finally, we compare that and we adjudicate the extent to which we believe or reject the null. All right, so if the test statistic is greater than the critical value, we reject the null. If it's less than the critical value, we don't reject the null. So again, just a reminder to let you all know. Now, start by working through example with steps 1 and 2. So in our example, you've really got 2 alternative hypotheses. Now, these are your research hypotheses, which we'll use to define the null in a moment. Here they are. The first research hypothesis is that this sample, this mean incarceration rate, this sample of 5 states comes from the South, right? So that it is equal to the mean of the southern states. That's your first research hypothesis. Your second, so I'm calling it H1B, is that it comes from the non-South. Now, from this, we can derive 2 corresponding nulls. The first null, right, if H1A says that they're from the South, the first null would be they're not from the South, meaning they're from the non-South. Okay, because really, when you only have 2 things like this, not South is the same as saying non-South. Okay, so then H0B, that's the null for H1B, would be that they're from the South. Okay, so we're going to set our significance threshold to 0.05. Now, we're actually going to be using a 2-tailed test, which I'll get back to in a moment. But we'll set it to 0.05. Now, working through steps 3 and 4. If we're looking to figure out whether a sample comes from a specific population, we want the one sample z-score. Okay, so we already talked about that. That's straightforward. Now, importantly, this is not in that flow chart from the last set of slides, right? And importantly, it's because it's really not that common in political science. Okay, we use z-scores in a variety of contexts, but not this one sample z-score. Now we have to calculate our z-score. Here's how you calculate a z-score. All right, straight from your textbook. Z is equal to the sample mean, which is x bar, minus the population mean. All right, so we're going to have to do this twice, once for the South, once for the non-South, divided by the standard error of the mean. So realize very quickly, right, if all you're doing is the numerator, and instead of SEM in the bottom, you have the standard deviation, and instead of X bar, you just do X. It's the same as the z-score you calculated before, right? This observation minus the mean of that variable divided by the variable standard deviation, right? But in a sample z-score, we're going to be using the sample mean minus the population mean, or the hypothetical population mean, divided by the standard error of the mean. Okay? So what the heck is that thing? What is the standard error of the mean? It's just the standard deviation of that sampling distribution. So to clarify, if we took 10,000 random samples of 5 southern or non-southern states and plotted the means, this would be our sampling distribution. And it is normally distributed. That's according to the central limit theorem. All right? So you get a normal distribution of all your sample means. They'd be tightly clustered around the true population mean. The standard deviation of these 10,000 sample means would be the standard error of the mean. Okay, so it's just a measure of variation around that sampling distribution mean, the true population mean. So how do we calculate it? Well, we calculate it by this, where sigma is the population standard deviation, which I already gave you, and that's divided by the square root of n, where n is our sample size. So it's 5 in this case. Okay. Now, of course, note I talked about this in the last set of slides, right? The bigger your sample size, the smaller your standard error of the mean will be. Okay, so as n increases, as you have a bigger sample, the standard error of the mean decreases. Why? Well, it's because you have less uncertainty due to a sample that should be more reflective of the population of interest. So let's calculate it for both the South and the non-South. For the South, the standard error of the mean is 194, okay, which is the standard deviation for the South, divided by the square root of 5, which is 194 divided by 2.24, which is 86.61. Do a similar calculation for the North, or the non-South rather, substituting in the standard deviation for the non-South, which is 180, and you get 80.36. Okay? So you'll notice, right, you have a higher standard deviation for the South than you do for the non-South. Therefore, you have a higher standard error. Now, if we had 100 states, which of course wouldn't be possible, you'd get a smaller standard error because you'd have a bigger sample size. Now we plug that into our equations for Z. Right? So again, we take the mean from our sample, which is 842, that's what it said on the post-it, minus the population mean. So for the South, that's 902. And you divide it by the South's standard error, 86.61, and you get negative 0.69. So you're less than 1 standard error away from the mean. For the non-South, you end up being over 3 standard errors above the mean. Okay, so you can kind of already tell which one is more likely to be the origin of this student. Okay, but let's keep teasing it out just so we see. So step 5, if you recall, in step 5, we go ahead and determine that critical value. Now, we determine critical values needed for the significance level of P equals 0.05. This is where things get a little bit tricky. Now, we consult what's called a z-table. Now, that's in Appendix B1 in your textbook. Now, what Appendix B1 shows you is it shows you the area between the mean and that z-score. Okay? Now, remember, we're not looking just for the mean of that. We want P equals 0.05. Now, we're going to be using a two-tailed test. So we want the area between the mean and z to be 47.5. Why is that? Well, if you double 47.5, what do you get? 95. So that's 95 bounded in by the mean. We want 95% of the data within that z-score. That means anything further away than that is going to be less than 5% chance of getting a sample that looks like that. All right, so that's our critical value. So we want something that tells us there's a 5% chance you'd get something further away from the mean above or below than that. So if you look in your z table and you try to find the area between z and the mean of 47.5, you'll find that that is under a z-score for 1.96. Okay? I'll go into some more detail on this in another slide. Okay, I'll work you through it as an actual example. Now, we compare our test statistic to that critical value. So for the South, our z-score is negative 0.69. The magnitude is less than 1.96. For non-South, it's 3.36. The magnitude is greater than 1.96. And this 1.96 should look familiar, right? Because we know that in a normal distribution, 95% of the cases fall within roughly 2 standard deviations, or in this case, standard errors, right? 1.96 is really that number. Within 1.96, standard errors is 95% of your observations. So in a sampling distribution, 95% of all samples should have means within 2 or 1.96 standard errors of the true population mean. Okay? So for the non-South, 3.36 is greater than 1.96. So step 7, the Z for the non-South is greater than our critical value. That means we can reject the null that the sample came from the non-South. For the South, we can't reject the null that the sample came from the South. So this dead grad student, poor guy or girl, is very likely a Southerner. In fact, they're very, very likely to be a Southerner, right? Because P is 0.0008, meaning there is a less than 0.08% chance that we would observe this observation, this sample, from the non-South. Okay, it's highly unlikely to observe a sample of 842 from 5 states in the non-South. But it's relatively likely in the South. Okay, so it means that they're likely to be a Southerner. So how do you interpret a z-score and its significance? Well, if it is significant, you say that it's highly unlikely that your observed sample comes from that population, that hypothetical population. So if your sibling says that Jill Stein's true feeling thermometer is 55, and you find that your sample is statistically distinct, that is p is less than 0.05 from that, then you rule out the possibility that this sample comes from a mean of 55, a true population mean of 55. Okay? Feel free to shoot me an email or contact me during office hours if you have questions. Again, I'm always willing to talk. If you want to contact me via GChat during office hours, you can, and we can set up a video chat through that as well. Please don't hesitate to reach out if you need anything at all from me. All right, so things are going to get a little bit hairier from here, but so far I think that hopefully this is a little bit clear. Okay, I will see you all on the next video. Thanks.